Okay, today's lesson is 9-4, ellipses, and this is something new that you have not done before. So I'm going to start off verbally by giving you a definition of it, and then I'm going to talk about the graphical definition of it. So first and foremost, we have an ellipse is similar to what we've done with the parabolas, and what we're going to do with the hyperbolas. But an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points is a constant. Okay, so we had a fixed point before with our parabola. That was called a focus. Well, now we have two of them. With the parabola, we had one. And the plural of focus is foci. So I have a fixed point. Ooh, my bad. And another fixed point. It'll go away. And if I find the distance from the focus to any point, okay, and I want to know what all of those points are, this distance, the distance from this focus to that point and this focus to that point, will always add up to the same number. Okay, so of course I have to show you with our interactive ellipse here. Here is one focus, here's another focus, and here's my point. And this distance here and that distance there, okay, and they tell you here, the distance from point on the ellipse to one focus is 11, point to the focus number 2 is 5, so we add those up, we get 16. So if you think about it, this is a string, and these 2 points are fixed, and I'm going to see how far I can go and where I can go with that string. And if you drag it around, you're going to see that PF1 and PF2 change, but the distance, the distance or the length of my string never changes. No matter where I am, that number stayed constant. Okay, so that's kind of what we're dealing with. Let's go label the important parts. So really what's important for you to know about these graphs is kind of understand what it is and know what the vocab means, because that's going to help you be able to identify the different things. Okay, so first off, you know that this point right here is your center. Okay, now the two that I just talked about too, let's see if that's what that's pointing to. Those are, which one of those? None of those are pointing to my focus. Okay, so I think this is pointing to this point right here, which is pointing to that. An ellipse, y'all, could be horizontal or vertical. It just means which way the longer axis goes, and that longer axis is called the major axis. Okay, the shorter one is called are those pointing to my, this one, this over here is pointing, the endpoints of the major axis is called a vertex. The shorter axis is always referred to as a minor axis. And there's doing that funky thing again. Minor axis. The endpoints of your minor axis are called a covertex. All right, this is the center down here. Okay, that wasn't supposed to happen. Come back. Go back. There we go. This is the center. This is the endpoint of the shorter axis, so that is a covertex. And did I label everything? And that's the endpoint of the longer axis, which is called your major axis. Okay, so I say that here. We have a major and a minor axis, and where they intersect is the center of your ellipse. And the endpoints of the major axis is the vertices that I just talked to you about, and then we have the covertices. Okay, now you need to know that, okay, your center is still HK that we've always had, and we're always going to have, okay? The other thing is, if you notice from our interactive ellipse, that the distance from any point on the parabola to one, golly, I don't know why this keeps doing this, to any point on the parabola, a point on the parabola to one focus, point on the parabola to the other focus is always a constant, and that constant is 2a. Now, 2a, if you notice, The vertices, these are the endpoints of your vertices. So 2A happens to be the length of your major axis, and that means the length of your minor axis is 2B. And that is something that's kind of important. If you see that this right here, that's a co-vertex, that's at B0. Up here is your other co-vertex, that's 0B, okay? Which is how we know that the length of our minor axis is 2B and the length of our major axis is 2A, okay? Now, you're going to see that in the equation, okay? But you're also going to see as I go through this, if you just understand what the basic ellipse is, you don't have to memorize a lot of the different formulas, like we got some formulas right here again. You don't have to get bogged down with them because I'm going to show you by graphing them. If you know the vocab, it's very easy to do these problems. Okay, now there are two important things that you need to remember about ellipse. One is this equation of A, B, and C. So B is the distance from the center to a co-vertex. A is the distance from, it tells you, well, it's here, but A is the distance, let me go up a little bit so you can see it right here. A is the distance from the center to the vertex, and then C is the distance from center to the focus. Okay, so if you remember the word focus has a C in the middle of it, then I'll help you remember that C represents that distance from the center to the focus. Now, you need to know how all A, B, and C are related, okay? That's the key. So how are they related? C squared is equal to A squared minus B squared. And the other thing you need to know about an ellipse is that A is always larger than B, because A is what I said describes your major axis. Okay? Now, the equations that you have for these are in standard form, okay, x minus h quantity squared plus y minus k, it's moving on me, quantity squared equals 1. Now, if it's horizontal, that means that the bigger number is under the x, so it's going to be a squared and b squared. So they'll say the same thing, x minus h quantity squared plus y minus k quantity squared equals 1. If it's vertical, then the bigger number is going to be underneath the y. So notice I'm telling you bigger number. I'm not telling you A or B. I mean, yes, you got to know that in certain instances, but more importantly, the bigger number tells you which way the ellipse is going to go. So let's go graph some. All right, this one says write an equation for an ellipse whose vertices are negative 4, 0, 4, 0, and foci are at 2, 0, negative 2, 0. So we don't have to graph it, but I'm telling you right now, whether you have a grid or whether you just sketch it on your paper, it's much easier to do with a graph. So I'm going to go plot negative 4, 0, that is a vertex, and 4, 0, that is another vertex, and the foci are at 2, 0, negative 2, 0. I might not have graphed this in the right order, but you got the gist of it. Okay, whether you choose to use the foci or the vertices or the foci, what is halfway between those is my center. So I know that the center is at the origin. Okay, so that means the top is going to be x squared plus y squared because I'm not adding anything to it. I didn't shift anywhere. Now, what goes under the x is how far did I move to get to the vertex, to get in the x direction. And that, of course, is 4 units. And so what goes, seriously? what goes underneath the x is 4 squared. I know that that's of course equal to a, which is important to know because center to the vertex is a, center to the focus is c, so c is 2. I have to go find this number here, which is b. So I come up to c squared equals a squared minus b squared. And what does c squared equal? That's 4. That right there is my a squared. So what is b squared? Well, you can solve that and know that it's 12. I don't need b, I just needed b squared. I don't have to graph it. I don't have to go any further. Now, people in class wanted me to graph it, so I will go ahead and graph it. What do? I go up and down the square root of 12, and the square root of 12 is a little bit less than 4. So I'm going to go 1, 2, 3, probably about 3.5. 1, 2, 3, and that's how I would graph this thing. I know the center is at 0, 0. I go left and right 4 units, up and down the square root of 12, and so okay, that was really bad. I'll try that one more time. Looking something like that. Okay, and what do you have to give me? You have to give me, you got to know which ones are the vertices. Again, if you graph it and you know the vocab, then you've got your terminology. That's a covertex. That's a covertex. You got to give me, and the foci, okay, which were given to you in the problem. Let's go to another one. This one says, write an equation of ellipse with hyperbola, no, write an equation for ellipse with vertices at -3, 8, and -9, 8, and covertices at 3, 12, and 3, 4. So I'm going to go plot that information again. So -3, 8 is going to be right here. That is a vertex. 9, 8 is right here. There's another vertex. That's enough to tell me what my center is. Okay? You can either count or you can use your midpoint. And that means add the 2x coordinates together. 9 plus -3 is 6, divided by 2 is 3, 8. But I'm going to go graph 1, 2, 3, 8. So I'm going to go check that. That would be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I know I got that right. Okay, so those are my vertices. Vertex, vertex. This is my center. And I'm going to go ahead and do x minus 3 squared over something plus y minus 8 squared over something. And I do this in steps, y'all, because there's so many pieces to it, and it's not really a lot of work that you can show. Okay, so next we have 312. 312, 8, 9, 10, 11, 12. So I'll put that up there. That's a covertex. And 3, 4 would be 1, 2, 3, 4. There's my other covertex. Okay? And for what it's worth, that's enough. This right here, to the vertex, is A. How far away is that? 6. 6 squared is 36. How far did I go up and down? That right there is B. And how far is that? 1, 2, 3, 4. So what's underneath there is 4 squared. And there's my equation. And if you wanted to graph it, you would just connect those dots and just do your best to not make them pointy. Not the best ellipse, but it's not pointed. Okay? All right. One more problem. Graph an ellipse. Find the coordinates of the center, foci, and lengths of the major and minor axes of the ellipse with the equation of such. All right, so, this looks like what you might have to do on a lesson check. So, I am going to have to complete the square with this. So, when I complete my square, I'm going to take this to the other side. So, I'm going to first group my x's together, and that gives me x squared minus 2x plus something, and then plus, I got to factor out the 4 because I can't complete the square if the coefficient's not 1. Y squared plus 6y, because I had to divide the 24 by 4, plus something equals, when I take the 21 to the other side, it's negative, and then I've got to add the first blank and add the second blank, but that second blank is in parentheses where everything's multiplied by 4. So, what am I going to put in those blanks? What goes in here is half of 2 squared. Don't need to worry about the negative because I squared it. So that means that's a 1. And then half of 6 is 3 squared, and that becomes a 9. So now I'm going to go back, and I'm going to factor. This is going to become x minus 1 quantity squared. Always takes this sign right here. Plus 4 times y plus 3 quantity squared equals, and negative 21 plus 1 is negative 20, so 36 minus 20 is 16. And we're going to put it in standard form. And so that means that I'm going to go divide everything by 16. So if you're asked to put it in standard form, you got to make it equal to 1. So this is going to come down to x minus 1 squared over 16 plus y plus 3 quantity squared over 4, because I got a 4 and a 16, equals 1. So this is the standard form of the equation of the ellipse. Find the coordinates of the center. So my center, of course, is 1, negative 3. So I'm going to go plot 1, negative 3. Find the foci and the lengths of the major and minor axis. Okay, so keep in mind, because people don't pay attention and they don't realize what's being asked. But on the major axis, stop it. Okay, whatever. Go away. Major axis. Y'all, I'm asking for the, oh, jeepers. Go back. I don't know what happened. Okay, major axis. It's asking for the lengths of these things. So how long? Now, I'm going to go ahead and graph it before I answer those questions, because you'll see that it's really easy once you graph it. I graph the center. How far do I go left and right? That's underneath the x, so I'm going to go left and right 4 units. 1, 2, 3, 4. 1, 2, 3, 4. How far am I going to go up and down? Under the y is 2. 1, 2. 1, 2. And then I'm going to connect. Okay, that was really bad, so let me try that one more time. Usually better at graphing ellipses. That looks a little better. Okay, that's a vertex. That's a vertex because it's the longer axis. This is a co-vertex. That's a co-vertex. Okay, you can label it if you want. So now you know if I ask you for those coordinates, you would give it to me. If I ask you for the major axis, I'm asking you how long it is. How long is that axis? From one vertex to the other is 8. How long is the minor axis? Okay, that's from one, that is from a co-vertex to a co-vertex, that right there, and that is 4 units. The lengths, and that's all they asked me for. So that is the vital information that you need to know for an ellipse. And that, I believe, is the end of our lesson. So if you have any questions, please come see me or email me. Thank you so much. Well, let me tell you, I just figured out I forgot to tell you about the foci. So we found the co-vertices and the vertices, but we did not find the foci. So how do you find the foci? You have to remember that relationship. C squared equals A squared minus B squared. Okay, so there is your A squared, there is your B squared. Remember, A is always larger. So C squared equals 16 minus 4. C squared equals 12. And C equals, stop it, C equals plus or minus the square root of 12, which you actually have to simplify that. If I'm asking you for this, plus or minus 2 square roots of 3. So if I ask you for the foci, then you would tell me the foci are along this axis because they're always along the same axis with your vertices. So which coordinate's going to change from my center, of course, is the x coordinate. So for your foci, you would just say that is 1 plus or minus 2 square roots of 3, comma, negative 3, because my y value didn't change. Now, the only reason you would give me a decimal, you don't ever give me a decimal. If I ask for the answers, you always give me exact answers. You would only need the decimal if you had to graph it. I'm not asking you to graph it, but you can if you want to. In that case, you would convert to a decimal. Now I'm finished. And so if you have any questions, please don't hesitate to come see me. Thank you.